we are going to discuss about the strength of materials. So in strength of materials, how to find out the shear force for simply supported beam and how to find out the shear force for cantilever beam, and also along with bending moments for two beams we will discuss along with the diagrams. So first, what is shear force? Shear force is denoted with SF. Shear force is nothing but the algebraic sum of the forces which are acting either left of the section or right of the section. For example, if you take simply supported beam, the forces are acting here, two forces. One is F1 force and another one is F2 force. If we consider here section as XX, if you take from this side, you have the two forces, that is here A and B, that is B and F1 force. So the summation of two forces F1 and B forces will give the shear force at this section. So the definition of shear force is the algebraic sum of the forces either left of the section or right of the section is called shear force. And bending moment. Bending moment is nothing but the algebraic summation of moments either right of the section or left of the section. If we consider section here only, so the moment of B, so who is having length as L, so the moment of B, this is the L by 2 and this is the L by 2. The moment at section this one, B into L by 2. So here downward force minus F1 into L by 2, which is equal to moment at this section. This is called bending moment. That means the summation of the moments of each and every force which are acting either left of the section or right of the section is called bending moment, which is denoted with Bm. So now we will discuss the diagrams, shear force and bending. Now the shear force and bending moment diagrams for different beams along with different loads, that means point load and UDL. So now I am taking the simply supported beam who is having the point load at center. That means if the total length is L, if we consider as total length is L, it becomes L by 2 because the load is acting at the center. For this center, we have to draw the shear force and bending moment diagram. So we have to draw the shear force and bending moment diagram, we have to calculate the support moments, that is A and B. So to calculate the support moments, we have to summation of bending moment which is equal to 0, we have to apply this condition. Then if I am applying summation MA equal to 0, so at A equal to 0 I am considering, then calculate from here minus, because it is going anti-clockwise, I am taking the moment at MA. MA is nothing but moment at A. So minus RB into total distance L plus, because the load is acting as downward direction, which is taken as clockwise direction, plus W into L by 2, because moment is nothing but which is equal to 0, because moment is nothing but force into perpendicular distance. So perpendicular distance is nothing but this one. So get the value of RB. RB equal to, so WL by 2, so by L. Yes or no? So this becomes W by 2. So RB value as W by 2. Same RA value also W by 2, because of which is acting center. This will take off and this will take off. So I will prove it. So RA plus RB equal to W. So we know the RB value. Substitute the RB value. So RB, W minus RB. RB value as W by 2. Take as LCM. So 2 is the LCM here. 2W minus W, which is equal to W by 2. So the RA value also W by 2. Draw the shear force diagram. So here I am taking upward force as positive. So I am considering as positive. So RB value as W by 2. This is the value of W by 2. There is no force in this section. So the diagram should be the line should be straight because no force is acting. Here which is acting downward direction, I am taking as minus. So W by 2 minus W by 2. So I am taking as minus here. Sorry, I am taking as minus. So here the value as W by 2 is there and which is acting downwards as W. So what will you get? Take as LCM 2. So W minus 2W which is equal to minus W by 2. So that means this is the positive, this is the negative. So you have to bring those things up to minus W by 2. So there is no force here and again you will get the straight line and again you have the W by 2. So minus W by 2 plus W by 2 which is equal to 0. That means this is the 0 comma 0. So it becomes this is the negative. So this is the shear force diagram for simply supported beam whose having point out as W at the center. And now we will discuss the